Solubility in chemistry. Solubility is very simple, like A, B, C. What is solubility? Solubility is just the amount of solute that can be dissolved in a solvent at a given temperature or at a particular temperature. So today, I'll be guiding you guys on the right formulas to use to solve solubility questions in your exams. But before that, let me show you something about solubility. Solubility now, this is solubility, right? It's just this. It is a solute plus a solvent to give us a solution. This is just what solubility entails. A solute that can be dissolved in a solvent to form what? A solution. Example of a solute is Gary. Example of a solvent is what? Is water. And what will it give you? To give you what? Sharpen solution. Another example is what? Is let's try this, is salt. Any salt at all, common salt, NaCl plus water. And what will it give us? To give us what? Salt solution. So that's just all solubility entails. Solute, solvent, solution. Gary, water, sharpen solvent. Salt, water, salt solution. That is just it. Do you understand it now? So I'm going to be giving you the formulas that you need to know to solve solubility calculations or solubility questions in your exams. Exams like WAEC, UTME, and the likes. So let's get right into it. Okay, let's continue. The board is rubbed off. Now, after you understand what I just did earlier, which is solute plus solvent equals to solution, the next thing I wanted to see here is this. So how did the formula comes in? We have, let me just say two formulas now in solving questions in solubility. The first one is solubility in gram per dm cube. Now this one just involves like we are checking the mass of the solute that can be dissolved in a solvent. So the mass of Gary that you can dissolve in water. So in that scenario now, the formula is equals to what? Is equals to mass of solute, which is always in grams, over what? Volume of solvent, which is in what? In dm cube. Now, when the volume of solvent is in dm cube, there's only a v multiplied by 1000. But when the volume of solvent is the cm cube, you can just make it easy and multiply by 1000. Or you convert it if you don't want to multiply by 1000. I hope you understand. That is it. But let me write it clearly for some of us that our eyes sees beyond the full job. Now, this is the first formula. And the second formula is this. Now, in this one is used to solve questions under molar solubility, or solubility questions that involve moles. So that one is this. There are two ways about it. The first, that one is solubility in what? In mole per dm cube. Now the first one, let me divide the board. The first one is this. Number of moles of solvent. Sorry, of solute. That was a mistake. Of solute over what? Volume of solvent. Or use this one I like using very well, which is same thing as mass of solute. Let me just call it mass of solute over mass of volume. Can be mass or volume of what? Solvent multiplied by 1000 over molar mass. I can either use any of these two. It works. Just remember that your solute is always in mass. Your solvent in this scenario now can either be in mass or in volume. Then 1000 over molar mass of that substance. That's of that substance that are given, which is mostly the solute. Are you getting something here? So these are the formulas for solving solubility. The first one is what? Mass of solute over volume of solvent multiplied by 1000 if the volume is not in dm cube. The second one is number of moles of solute over volume of solvent. And this one, under this one still, is what? Solute over solvent multiplied by 1000 over molar mass. Now, if you have understand these formulas perfectly well, check it out very well. Let's now move on to solving, I think, one or two questions, and then I'll give you something to try on your own. Ta-da! So the question goes, calculate the solubility in mole per dm cube of 40 gram of CuSO4 dissolved in 100 gram of water at 120 degrees Celsius. And then we're giving the atomic mass of each of the elements. In this question, how do we solve it? I think since it involves mole per dm cube, we should know the formula to use. Now let's go. That will be equals to, let's use that second one. I prefer the second one in this case. Solute over solvent multiplied by 1000 over molar mass. Now what's our solute? Our solute here is this, 40 gram. That's of CuSO4. What's our solvent? 100. That's of water. They multiply by 1000. Then what is our molar mass? Let's solve it. CuSO4. CuSO4. Cu is 64, S is 32, then O is 4 times 16, that's 64. Everything that is equals to what? 160. So over 160. So that's it, equals to 40,000 over 16,000. Then let's divide out with So you went 40 over 16. That's equals to 2.5. Yeah, that's 2.5. Then what's the unit? Mole per dm cube. Ta-da! We're done. Now let's try number 2 before I give you something to try on your own. So question number 2 goes like this. The solubility of KNO3 at 15 degrees Celsius is 0.5 mole per dm cube. Calculate the mass of this salt which was deposited when 1 dm cube of solution containing 1.96 mole per dm cube of the salt was cooled from 100 degrees Celsius to 15 degrees Celsius. And then we're given molar mass of KNO3. This question, if you observe it very well, you will see that we have 2 different solubility and we have 2 different temperature. So which means it will be kind of tricky. Now, to solve this kind of question, there are 2 ways to solve it. Either use the formula I give you, which is a bit longer, or use this faster method. Now, I'm going to show you the longer method first, the normal formula, and then we'll do the faster method. This is the longer method. So, the longer method. But before that, let's bring all our parameters out. I think we have solubility at 15 degrees Celsius, which is equals to 0.5 mole per dm cube. Then we have solubility at 100 degrees Celsius, which is equals to 1.96 mole per dm cube. Okay, so sharpen is here. The question said it was cooled from 100 degrees Celsius to 15 degrees Celsius. It's that interval, the one in between. That's what we're looking for. So what do we do here? Let's get the solubility now. The one in between, which is 100 degrees Celsius minus 15 degrees Celsius. And that will give us a solubility of what? Of 1.96 minus 0.5. Now if you subtract it, the solubility you'll be getting is 1.46 mole per dm cube. Right? So after I've gotten the solubility now, this solubility we'll be using to look for the mass here. Where's the mass? This mass here. I hope you're following. Now, so let's go then. Now if I just say solubility is equals to solute over solvent multiplied by 1000 over molar mass. Since solute is what we're looking for, the mass of solute, mass of this salt, the solute. So we can say solubility is 1.46 equals to, what's the solute? We're looking for it, so let's use X. And what's the solvent? No, solvent is calculate the mass of this salt which is to 1 dm cube. 1 dm cube, right? So that's 1. So since we are multiplying by 1000, let's change this one to 1000, or if I leave it as 1, anyone wants 1000 times 1000 over, what's the molar mass? 101. So if you want to cross multiply, that will be equals to, that's 1.46 equals to 1000x over 101,000. So then cross multiply, that will be 1000x equals to 1.46 times 101,000. That will give us 147, 460. If you make the ball is already choked up. If you make x the series of the formula, I think I'm going to rub the cup. I don't want to rub up the question because of the second pattern you can use, the faster method. Okay, so 1000. So if you make x series of the formula, that will give you x equals to 147 460 over 1000, right? So that will give us s is equals to 1.47.46, which is finally equals to what? 1.47 gram. So that's the mass of solutes. So that's the mass of solutes. Tada, we're done. So I don't know. If you prefer this one, you can use this one. But there's a faster method you can use, in which you involve the usage of formula for moles. If you need formula for moles, which is equal to mass over molar mass, it is more faster than this. So let's try it out. Okay, so I've rubbed off the board. Let's try the second pattern, the second method. So the second method now. So we still follow the same routine, which is we have at 15 degrees Celsius, which is equals to 0.5 mole per dm cube. At 100 degrees Celsius, which is 1.96, same thing. So after addressing this now, the thing here is if you are involving moles, yeah, what you need to understand is what you need to understand is this. 0.5 mole per dm cube also means that what 0.5 mole for 1 dm cube. 1.96 mole per dm cube means what 1.96 mole for 1 dm cube. So the mole in this case is what 0.5 and 1.96. Do we copy? So if you are extracting only mole from it, I want to understand what the mole that was cooled from year to year. That will be 1.96 mole minus 0.5 mole. That's the amount of substance that was cooled. So 1.96 mole now to 0.5 mole will give us what? 1 point, or let me make it easy for us, mole minus 0.5 mole. That's 1 point. Sorry, that's that will give us 1.46 mole. So you have gotten mole. Now with this mole, now we can now apply the formula that says mole is equals to mass over molar mass. And what's our mole? 1.46. What's our mass? Our mass is unknown. This is what we're looking for. What's our molar mass? 101. And that is equals to what? X is equals to 1.46 times 101. And that will give us what? That will give us 147.46, which means or which is approximately equals to 147 gram. Final answer. You can see this one is just like 3 steps. Very easy, very straightforward. So spend the next 3 seconds or 5 seconds gazing at it. So I'm going to give you something to try. Feel free to drop it in the comments. I will check it out. Let me write it out for you guys. So try this out and drop your answer or your working in the comment section. Don't forget to like, share, and follow me on TikTok or subscribe to my YouTube channel. Once again, welcome to Nelson Learning Space.